So welcome everyone, thanks for coming. Basically we had 5 people attending different aspects from Cognizant to the Angular conference, which was held finishing on the 22nd of last month, and it was a series of workshops which then culminated in a conference. So we're just basically going to go over some of our impressions and highlights from our perspective, what we thought was interesting. I attended, along with Matt, a workshop on the NgRx architecture, which is part of Angular, although it should be fairly familiar also in concept to a number of React developers here, because it's influenced strongly by the Redux architecture. So some of the things that are applicable are also applicable to Redux, but there's some specific Angular twists to this thing, which again doesn't rule out applications to Redux, but it's the way the Angular development went. But basically, I just wanted to introduce NgRx, or the Redux style architecture, which is basically a action-driven or event-driven, you could argue, architecture which essentially mutates or modifies an application state, which means a single page application keeps its state in one place and essentially controls its evolution through a system of actions. It makes it a more quantified, it makes it easier to basically describe the behavior of a single page application, and it makes it easier to define how functions should be added to the system. So I'm using this animation as something that is a go-to. Anybody who knows me knows this animation because I use it a lot. Essentially what we have here is the state, which is just a JavaScript data structure, which is then represented in the view of the application, that is the HTML. So anytime the state changes, the view will change. The view may emit more actions in the form of key clicks or user input, which is fed back, and essentially the reducer is the way that the state is modified. It's the only way. I'll come back to that. And then if there's any kind of stuff that goes off to the back-end servers or requires any kind of asynchronous action, that's handled through what they call middleware in the Redux architecture, but in the NgRx world it's called effects, as in side effects. Similar terminology is used in that. So basically, state management. The main thing about NgRx is idiomatically Angular, so it's written in TypeScript. It's using more of the Angular conventions, and it builds observables and streaming in at a fundamental level, which isn't necessarily the way the Redux architecture works, where you've got different ways of going. It's usually handling what's called the middleware. So there's a particular way in which Angular prescribes the way these architectures should be done. So I'm basically describing the architecture. Actions are just, as I say, event-type objects which have a string which identifies the type of action and a payload, which is just basically any kind of data. Usually we would define this as TypeScript, so each of these actions is defined by a class, and which means that we can be a little bit more rigorous in terms of making sure that the code is receiving the data that it's expecting to receive. So actions get dispatched, and essentially from NgRx's point of view, it's a stream of actions. A stream is a specific type of abstraction, which I'll go into in a minute. Actions can come from anywhere. They can come from the user, so when a person clicks in something or types into a field, hits a submit button, works with some sort of interactive component, it could produce a series of actions. They could come from server push notifications, totally unexpected from somewhere, suddenly something comes in. They could come in from WebSockets, they could come in from timer events, or they could come in as the responses from AJAX calls for detailed information coming back from the server. These all generate actions. Everything is driven by actions. So we can also look at the state of the application as I said, it's basically just a JavaScript data structure which changes over time. So if you looked at it you've got the state in this particular situation, something happens to it, and suddenly it's basically become a new state, which is state 2, then state 3, state 4. So you can, if you look at this from a stream point of view, it's a stream of states. And if you view state evolution, meaning the change of your state over the course of the application as a stream, it's a stream of states. Again, the same kind of abstraction as streams. The reducer, which should be familiar to anyone who knows something about redux, is essentially the only way that you can modify the state. Essentially, it takes the current state, feeds it into the reducer, and you get a new state. It's just a loop. And the other ingredient is the old state plus the action. So those two things, a reducer is essentially just a function. Old state plus action gives you a new state. And those functions have certain restrictions. They have to be pure functions. They just have to be basically functions in the mathematical sense. So that's the basic model of a reducer. This is what they look like. They're just a simple switch statement, or if then else. If the action is this, then create a new state here. If it's a different action, then create a different type of state here. So basically, essentially, we take the old state, we make some changes to it, override a few properties, and return the result. If it doesn't recognise the action, then it just falls through to the default, which is to return the existing state. And you can see in this diagram, old state plus action passes through the reducer gives you a new state. The view, all the view is it's a function of the state. So you can view it as, you can see it, that all of that DOM manipulation and stuff that Angular uses, templates and so on, are really just a function that takes the state as its input, and it only updates if there's any change in that state. But that would be an inefficient model if all of the view of all your subcomponents were all watching and subscribing to changes in the state. It would be, then you might be making a small change in this part of the state, and it would be updating all these other components, and that would be inefficient. So you can narrow down your interest in the state by using what are called selectors. Selectors basically take a subsection of the state and turn it into a stream. So essentially you subscribe to a selector. So if you're only interested in the title, maybe your component is just showing the title bar or the heading of a page, it would select the part of the stream that it's interested in and only be notified when that particular part gets changed. So that means that there's not a lot of unnecessary updates happening. It essentially is very economical. And they have a number of strategies which they recommend in terms of the design of selectors. This is one of the biggest performance areas when you want to make your application very lightweight and efficient. And also in terms of how you mark certain components as having a change detection strategy, which is part of Angular. It's a little bit quirky, some of their terminology in Angular, but one of the things that they're essentially saying is that dumb components are only interested when their inputs change, whereas some of the other container type components are much more interested when anything changes. So you mark certain components as having a different change strategy. And as I say, the usual components, the buttons and the input boxes, would all normally be marked as on push change detection strategy is on push. That's just an optimization, and basically the workshop went through some of the aspects of how to make these applications as efficient as possible. NgRx by itself, though, is a purely synchronous system. That means it all basically happens immediately. Actions, when they get dispatched, are read immediately by the reducer and acted upon immediately, which is all fine, but it doesn't make sense. Therefore, to talk about synchronous processes such as making calls to the back end, which are obviously going to happen a long time after you've triggered them, or a period of time after you've triggered them. So that is done through what are called effects. Effects, the equivalent in Redux is middleware, and this is sometimes you see people using funcs, you see people talking about Redux Saga. You may also hear about Redux Observable. well, this is most closest to Redux observable. It uses observables which are an abstraction which is similar to promise. A promise is something that basically you can kick off something and then it promises to give you something in the future. An observable, though, is a stream, so it can return more than one result, unlike a promise. They can be cancelled, unlike promises, and they're lazy. In other words, they don't fire until you show an interest in them. So you can set up an observable, but it won't actually do anything until somebody subscribes to it. So there's a series of reasons why you should use observables in preference to promises, and this is probably the main value proposition that Angular puts forward, is putting observables, which are slowly becoming standardized and will probably become part of the JavaScript spec in the same way promises did. Basically, you want to put them right in the center of the architecture of single-page applications. So keeping an eye on the time. So I just want to zoom into that part of the drawing, which is essentially actions come in and actions come out again. So you have to wait because the animations are subject there. But there's the action, which basically effects just sit there and watch actions go past, and if they're interested in them, they might go, oh, while that's going past, I'm going to grab it, I'm going to do some side effect, which might be go off into an AJAX call, and then sometime later, dispatch another action. So middleware or effects, they take actions in, they don't interfere with the action, but they may emit further actions. So if you, for example, saw an action which is get me the list of clients, the effect would say, okay, I'm going to kick off an AJAX request to go off and do that. And when that comes back, I'm going to feed, it's going to be translated into further actions like, I have received a list of clients, here it is. So actions in, more actions out is the basic idea behind effects. So effects use what is called observables. The library that is the only dependency, as they say in Angular, they have only one dependency in the Angular framework, and that is to an observable library called RxJS, which is a very widely used library and worth learning. So basically, I won't go too much into the details. I can answer questions if you want to go into the details, but essentially, it's sitting there and it's overlooking particular actions and may or may not fire off AJAX requests and may or may not return new actions. So you can see actions in, possibly more actions come out. And the actual application is unaware of them, that's why they're considered effects. They're out on the side somewhere and feeding new actions into the system. Observables are asynchronous like promises, but they can be tested synchronously using unit tests. And to rigorously test a observable stream requires adding a different time system, basically injecting time into the system so it can execute immediately rather than in real time. And they use these things which are called marble diagrams, but basically to give you a sense of basically the different processing steps. One stream turns into another stream, or one stream and another stream get merged into a third stream. These are kinds of models. They're all time-based models that you use. And your tests reflect that kind of time-based representation. I'm not going to go into the details other than to say that this is a unit test where you set up a series of things and then you can expect certain results. So you can expect that the output of the stream will look like this because you've set it up to do this. So it'll be a way of basically testing synchronously what would otherwise take time to execute. And my final point was that there are ways in which reducers modify state. One of the strong recommendations that they came through with in this particular workshop was you should normalize the data so that you're not dealing with redundant or multiple copies of the same data. Instead of having an array of complex types, which might in themselves have extra types, you would store it as an array of IDs and keep those IDs in a map of some sort. So essentially, the reducers have a particular style which encourages data normalization, and they have a couple of libraries to help that job along. One of them is called NgRx/entities, but you can do it yourself. It's just essentially, the reason why you would want to even do that is, apart from normal sort of database things of normalization is a good idea, is that it's more efficient, and it also enables you to make copies of your state faster because you do shallow copying rather than deep nested complicated copying. And so that's it for me. Thank you.